A warm greetings to one and all. In this session, let's learn about K-means clustering algorithm in detail. As a part of introduction, we all know that unsupervised machine learning is the process of teaching a computer to use unlabeled dataset and enabling the algorithm to operate on that dataset without any supervision. The key objective of clustering is to identify distinct group of dataset based on similarity within the given dataset. The most popularly used clustering techniques are K-means and hierarchical. K-means clustering is unsupervised machine learning algorithm. It is mainly used for partitioning a data into predefined number of clusters. The key objective of K-means algorithm is to organize the data into clusters such that there is high intercluster similarity. That is, we can see here in cluster 1, by considering two data points, there should be high intercluster similarities and low intercluster similarities. That is, if you're considering two clusters, cluster 1 and cluster 2, and taking one data point from cluster 1 and another data point from cluster 2, there should be low intercluster similarity. An item will only belong to one cluster, not several. That is, it generates a specific number of disjoint non-hierarchical clusters. K-means uses the strategy of divide and conquer, and main objective of K-mean algorithm is to minimize the sum of distance between the points and the respective cluster centroid. Let's check out the terminologies used in K-means clustering algorithm first. So first comes data set. So the data set which we are using here is x1, x2, x3 up to xn, which consists of n observations of variable x. The next terminology is cluster center. In order to form the cluster, we introduce the vector mu k, where k is equal to 1 to k, and each vector mu k represents the center of kth cluster, which is also known as centroids of cluster. So let me give you an example here. Let's consider this as cluster k, where the center point of the cluster is represented by the vector mu k. So it is also known as centroid of the cluster k. So hope you understand the cluster center. The goal is to find the assignment of data point to cluster as well as the set of vectors mu k. So we need to find the data points which belongs to which cluster and also the centroids of the clusters, which is also known as mu k, such that the sum of squares of distance to each point to its closest vector mu k is minimum. So let's have an example here by considering the data point x1. Here, the sum of square of distance between the point x1 and the vector mu k, which is closest to the point x1, is minimum. So we are assigning the data point x1 to the cluster k. If you're considering the data point x2, the sum of square of distance between the x2 and mu k is not minimum. So we are not assigning this x2 to the cluster k. So hope you're clear on the objective. The next terminology is binary indicator variables. For each data point xn, introduce a corresponding set of binary indicator variables Rnk belongs to 0, 1. That is, it is a cluster membership of binary form, where k is equal to 1, 2, 3, 4 up to k, describing which of the kth cluster the data point xn is assigned to. So, if data point xn is assigned to the cluster k, then Rnk is equal to 1 and Rnj is equal to 0 for j not equal to k. So, this means that j and k are different clusters. So, this is also known as one of k coding scheme. So now let's have an example for better understanding. So the binary indicator is used for two clusters. So it is named as one of two coding scheme. So let's consider the data point x1 here, where the binary indicator R11 is equal to 1, 0. This implies that the data point x1. So the first one and R represents that data point x1 and the second one represents that the cluster 1. That is, the data point x1 belongs to the cluster 1. So the binary indicator is given as for the first cluster, it is represented as 1 since it is present in cluster 1. And in the second cluster, it is represented as 0 since it is absent in cluster 2. Now let's consider the other data point, that is x2. So the binary indicator for R22 is assigned with 0, 1. This implies that the data point 2 belongs to cluster 2. So the first cluster is represented as 0 since it does not belong to first cluster. It is absent in first cluster and present in cluster 2. So for that we have assigned the value 1. So this is what the pictorial representation where the data point x1 belongs to cluster 1 and the data point x2 belongs to cluster 2. So this is what represented in binary indicator. The next terminology is a distortion measure. We can define an objective function. Sometimes it is also called a distortion measure. It is given by j is equal to summation of n is equal to 1 to n, summation of k is equal to 1 to k, where r n k and absolute of xn minus mu k the whole square. It represents the sum of squares of the distance of each data point to its assigned vector mu k. So hope you are clear in terminologies used in k-means clustering algorithm. Now let's learn in detail about k-means clustering algorithm. Our goal is to find the values for r, n, k and mu k so as to minimize the objective function j. Let's consider these data points as input data set for our k-means clustering algorithm. Step 1 is initialization. So we start by choosing initial values for the cluster centroids mu k. So let me consider I need 2 clusters from this input data points. So I randomly choose the initial value for cluster centroid mu1 for cluster 1, which is represented in red color star, and similarly the initial value for cluster centroid mu2, that is for cluster 2, which is represented by blue color star. Step 2, it is also called as assignment step, estimation step or E-step. For each data point xn, we assign it to the cluster whose centroid is closest to it and it is expressed as Rnk is equal to 1 if k is equal to arg min j of absolute xn minus mu k the whole square. That is, if sum of square of distance of each data point xn to the closest vector mu k. If so, it is assigned to the cluster, else it is not assigned to the cluster, that is 0 otherwise. So in this diagram, we can note that if sum of square of distance of each data points are closest to the cluster centroid mu1, then it is assigned to the cluster 1, which is represented in red color star. If sum of square of distance of each data points is closest to the cluster centroid mu2, is assigned to cluster 2, which is represented in blue color star. Step 3 is centroid update step, maximization step or M step. After assignment step, the next step is to update the centroids based on the new assignments. In order to find the new centroid mu k, we minimize the function j with respect to mu k by taking the derivative of j with respect to mu k. Therefore, dou j by dou mu k is equal to dou by dou mu k summation of I is equal to 1 to n r n k absolute of xn minus mu k the whole square. So this can be simplified as dou by dou mu k summation of I is equal to 1 to n r n k xn minus mu k transpose xn minus mu k. So this expression is equivalent to summing the square difference of the individual component of vector xn and mu k. Here, the transpose is used to ensure the correct matrix multiplication between the two vectors. Xn minus mu k, the transpose, is the corresponding row vector and xn minus mu k is the column vector. Next, we need to apply the chain rule and we get 2 summation of I is equivalent to 1 to n r n k xn minus mu k is equivalent to 0. It is equated to 0 in order to get the minimized j value. By simplifying this, we get the value summation I is equivalent to 1 to n r n k xn is equivalent to summation of I is equivalent to 1 to n r n k mu 1. So we are simplifying this term and we are getting this value. In order to solve the mu k, we divide summation I is equivalent to 1 to n r n k by both the sides. Now we get the value for the mu k. Mu k is equal to summation of I is equal to 1 to n r n k xn divided by summation of I is equal to 1 to n r n k. The denominator summation n r n k is the number of data points assigned to the cluster k. And so the name of the algorithm is k-means clustering algorithm. From this diagram, we can notice that based on the previous assignments of the data point in the cluster 1, now the cluster centroid 1 is being updated. That is, the red color star, it was earlier here in this diagram, we can notice here, but now it is being updated here. So the cluster centroid 1 is being updated for the cluster 1. Similarly, based on the previous assignments of the data points in cluster 2, now the cluster 2 centroid is being updated. That is, the blue color star, earlier it was here, now it is being updated here. You can notice it clearly in this diagram. So this step is called as centroid update step. Step 4 is convergence step. The process of alternating between the step 2 and step 3 is repeated until convergence. So we can see here in this figure, we can notice that based on the updated centroid value of both the clusters, the data points are being reassigned here. Now we can notice that few data points which is being assigned earlier to cluster 1 is being now assigned to cluster 2. So in next diagram, now we can update the centroid for this particular cluster 1 and also for the cluster 2. After that, we can notice that the data points has no changes based on the updated centroid values. Similarly, in cluster 2 also, there is no changes in data points after the updated centroid values. It means that we have reached the convergence. Convergence is typically reached when the assignments no longer change or the change in objective function j becomes negligible. So this is what our final output where we have two clusters. So this is cluster 1 and cluster 2. Hope you are clear on k-means clustering algorithm with this example. The plot for cost function j is given in this figure. We can notice here. Here, this blue color dot represents the cost function after performing the estimation step, whereas this red color dot represents the cost function after performing the maximization step. We can see here this green line represents the quick decrease in cost function since k-means algorithm is effectively clustering the data point. So here we are using the elbow method in order to find the optimal number of clusters, which is the main goal of elbow method. We can look for the elbow point here in this diagram where it decreases in inertia slow down significantly. Here it seems that around k is equivalent to 2 where the graph flattens and suggesting that 2 cluster might be the optimal number for this example of data points. So hope you are clear in k-means clustering algorithm. Thank you all.